so we're going to be working on pages 3 through 5, mostly just 3 and 4, and then the top of page 5, you just have like a little journal thing you have to do. So on question number 4, it says, Graciela is trying to solve the quadratic equation, bless you, x squared plus 2.5x minus 1.5 equals 0. I think I need to use the quadratic formula because of the decimals, she tells Walter. Walter replies, I'm sure there's another way. Can we rewrite this equation so there aren't any decimals? So for part A, it says, what is Walter talking about? And they want us to rewrite the equation so that it has no decimals. Okay? So sometimes if you see decimals or fractions obviously you want to use fraction busting, but with decimals, you can see right here that has a tenth and that has a tenth. So some people would just automatically multiply everything by 10. That would work. Or you can multiply everything by 2 since they're 0.5s. They're halves. So if you multiply half, you're going to get a whole. So we're going to take 2 and multiply it times x squared to get the 2x squared. We're going to take the 2 and multiply it by 2.5x to get 5x. And then we're going to take 2 and multiply it by the negative 1.5 to get minus 3. And then obviously 2 times 0 is 0. So we've got this new equation, 2x squared plus 5x minus 3, and our decimals are all gone. Okay? CPM refers to that as rewrite, okay, because it looks like a whole new equation. Any questions on A? No. All right, for part B, it says rewrite your equation again so that you can solve it without using the quadratic formula. Then solve your equation. Be sure to check your solutions with your graphing calculator using Graciela's original equation. Okay? If you like the quadratic formula, great. Use the quadratic formula. But this one is sort of a lot more easily factorable and can be done faster than using the quadratic formula. So I used the box method on this one. So I filled in the 2x squared and I filled in the minus 3. Now these two boxes need to combine to get your 5x. Okay? With the 2 and a 3, you can get 6. And with a 1 and a 1, you can get 1. Okay? So let's see. For the 2x squared, it's going to be x and it's going to be 2x. There's nothing else it could be, right? Then for negative 3, you have to have a 3 and a negative 1, but the signs could change and they could change positions. How do you know which is which? You need to have the 3 so that it multiplies by the 2x, which would fill in what in this box? The 6x would fill in this box. Okay? 6x is going to get us really close to 5x. We just need to subtract an x. That's why the negative 1 goes here, because negative 1 times x would give us negative 1x in this box. So you want to fill in 6x, and you want to fill in minus x or minus 1x, however you want to write it. And then that's going to give you your two binomials. The binomial across the top is 2x minus 1, and the binomial along the side is your x plus 3. Set them each equal to 0, and then solve them each independently. Okay? When you have no coefficient, like on this one, it's pretty easy. It's just the opposite, right? But when you do have a coefficient like this one, you're going to end up with a fraction. Okay? So always look for a fraction when you have a coefficient here, 2, 3, 5, whatever it is. All right? Any questions on part B? How many of you would just jump straight to the quadratic formula? A couple people? I mean, there are people who just like quadratic formula, and for them, they've done it so many times, it's super fast. All right, awesome. Question 3-5 says, solve each equation, if possible, using any strategy. Name your strategy and check with your teammates to see what strategies they choose. Be sure to check your solutions algebraically. Then ask your teammates, did you choose the same strategies? Okay? So there are a couple today that lend themselves well to the weird one we learned yesterday, the look inside. Okay? In fact, I would say if you were going to use look inside, A is a good one for that because it's absolute value. So I'm leaving A for you because I think that one will be nice. And I'm leaving B for you because I think that would be a good undo. Okay? But let's flip over to page 4. On page 4, I'm going to have you and your team do D, F, and H. So the right-hand column. And we're going to do C, E, and G together. So for C, we have the binomials 2y minus 3 and y minus 2 set equal to negative 12y plus 18. I'm going to use the rewrite strategy on this one. You might not know what strategy you use until you're done. So if you leave that blank at first and then fill it in at the end, that's fine. Or if you do the problem and you're like, I have no idea what I used. You can ask and I'll look at it and say, oh, you used blah, 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 blah. Because some of you don't think about, I'm using this strategy or I'm using that strategy. You just do it, right? Okay. So what did I do? I FOILed here. I multiplied first, outside, inside, last to get the 2y squared minus the 7y plus 6. Left that equal to the negative 12y plus 18. Then to set it equal to 0, I added 12y to both sides. And I subtracted 18 from both sides. That gave me the new binomial 2y squared plus 5y minus 12 equals 0. You could actually use the quadratic formula from here if you wanted to. Or you can do what I did and use the factor table. So again, I filled in the first term here, the third term here. And then I had to figure out what these two boxes would get in order to make our 5y. Okay. To get our 5y, I needed 2y and 4, which would be our 8y. So this box is going to fill in with 8y. And then for this box, we need to subtract 3y. So negative 3 times y would be negative 3y. So positive 8y minus the 3y is going to combine to get the 5y. Okay? Then I just took the top binomial and the bottom binomial, set them each equal to 0, and solved independently. Right? Then I looked back at it and I said, okay, I used rewrite. Any questions on C? Okay. E is a good one for looking inside. This is a very special one where we have absolute value. And I would say looking inside is probably best with absolute values, maybe even square roots or and absolute values. All right. So something inside of that absolute value should be equal to negative 6. Okay? When you take the absolute value of a number, you're always going to get a what? A positive. So this one's weird because they're trying to trick you. This one is actually no solution because you should always get a positive. But the other one I pointed out on page 3 has a positive number. That's why I left that one for you, not this one. Because this one's not solvable and it's kind of tricky. Okay? But if this had been positive 6, you would say that whatever's inside should be equal to positive 6 and should be equal to negative 6. Two things, because with absolute value, you're going to have two answers. And they're not always just opposite of each other. Feels like they should be, but they're not. Okay. And the last one we're going to go over together is G. We have x minus 3 quantity squared minus 2 equals negative 5. And I used the strategy undo. So the first thing I did was I added 2 to both sides. So if we add 2 here and add 2 here, we get negative 3. And then we're undoing the squaring, which is square rooting. So we square root both sides. But now we're going to have this negative under the radical. When you have a negative under the radical, think of it as negative 1. So the square root of -1 is just I. Then when you add 3 to both sides, you're going to get 3 plus I rad 3 and 3 minus I rad 3. Okay? With your groups of 4, you're going to come back and do D, F, and H. And then the other 2 from page 3. Anybody still writing? No? Okay. And at the top of page 5, you're just going to do your learning log, and then that's it. We're going to save 312 for tomorrow. Okay? All right.